password. So you can log in and you can practice. Okay. So yeah. So I am also, even in my system, I don't have Aspen. So I'm also using the Cape Lab computer through any desk remote access. So let's start. So I hope you're able to see my screen.
Yes, sir.
Yeah, thank you. So this is Cape Lab computer. And these are the Aspen modules. There are many Aspen modules available. Initially, we will go with Aspen Plus. There are many modules available for Aspen. We'll go with Aspen Plus. And latest version in Aspen Plus is version 12. So this is the latest version. So I'm just opening this Aspen software because many students are using the computers. So this one important thing all of you have to note that these computers were the access to these computers were given to other students also, for their MTPs and BTPs. So they'll be using their softwares. They'll be running their softwares while you're accessing Aspen Plus. Please don't close others whatever they're using. Don't close other windows. Like for example, the student is doing his console simulation. The MTech student is doing console simulation. So you don't stop or close his simulation. You simply open your Aspen and you practice it. And also don't close his files or delete his files. So, and you can also see whenever you log in, probably already know it, how many users are currently logged in, right? If like more than one user is logged in, there will be multiple sessions running. If somebody else log in, then you can do chat and you can discuss with him and you can accordingly practice it, right? I found these computers are inactive or not used until 11 a.m. in the morning, and again these are inactive from 1 to 4. Most often it is active in the night time, so if you can access in the daytime, that will be good. So let's start new simulation. So just click on the new simulation. So this is the new simulation. In DWSim, as soon as you open the software, a pop-up window will open. In that pop-up window, you need to select the components, you need to select the property package. Same thing also we have to do. But here there is no pop-up window. So this is the window will be opened. So here, first of all, we need to enter the components. First of all, we need to enter the components. So we can use the name. We can use the name or we can use the formula, chemical formula. For example, if I want to do ethanol, if you want to add ethanol, just type ethanol, and then it will automatically fetches this. If you see these two things and the CS number, that means all the data is there. All the data is there. It exists. And let's say water. So just adding the components by typing the name. We can also do the search, but more easily is giving the component name, either chemical formula or the name of the component. So by giving that way, you'll able to define the components. So once you define the components, right, you have to click on next. You have to click on the next. So this next input, you can see here, next input will make you to take the right window. Otherwise we can also do this, you can also go by this, you can also go by this one by one, and more easily is if you click on the next, it will take you to the right place. So next one is methods. You can see whatever we are going this, first we have to select the components, then you need to select the methods, right? Once you're done with the methods, then we'll go to the simulation, then we can go to safety analysis, then we can go to energy analysis. So this goes that way. First properties, then simulation, then say whatever if required safety analysis or if required energy analysis. But first properties, then simulation. In the properties, there are two. One is defining the components and next defining the methods. Here method is nothing but the property package. Here method is nothing but the property package. You can select here, this is the base method. You can select the same, whatever property packages we have seen in DWSIM, all those things will be there. All those will be there. So for example, we have the Barun Ketan, that is black oil properties. Kiowa cedar. Then we have the, this is some additional one which is not there in the DWSIM, cubic plus association US package. Then we have the alkalite NRTL, then we have the symmetric alkalite NRTL, then we have the IAPWS standards, then we have the ideal Raoults-Law, then we have the NRTL, then we have the all the property packages you can see, Peng-Robinson, poly-NRTL, SRK, solids, SRK, and we have the UNIQUAC, all the Wilson, picture, all these, the whatever you see in DWSIM, same thing will be there. Now here we have selected ethanol and water, so we will take either NRTL or UNIQUAC or UNIQUAC one. So we'll take NRTL property package. So as soon as you do the NRTL property package, you can go to next. So it will show you all the interaction properties, interaction parameters. Based on that property package, it will show you all the interaction properties. In DWSIM, this will not be displayed externally, but all the same parameters also will be there in the DWSIM. Now, if you wanted to see whether you have selected the right property package, all the property methods are there, you just click run property analysis. So it will check whether the selected property package has the sufficient information, sufficient data is available for these components are there, will be known. If table generation completed means all the properties, whatever is required for the simulations is available in this with this property package. But that is correct or not, it will not able to say, because we have to compare with an experimental data. But whether required parameters, required details available to generate the data or not, it will tell you. So that way we define the components, then we define the property package, and we don't need to do the custom units. If required, we can do it, because we can every time we can change the unit systems whatever way we want. We don't have any restriction with the unit system, and we can do customization also if required. So that is the way we define the properties. Now we go to the simulation. So this is same as, you can see the window is same as the whatever options we have is similar to the DWSIM. In DWSIM, as soon as we open it, a pop-up window will open. That will tells you to define the components, select the components and define the property package. So just now we have done that. As soon as done that, you will see such blank screen for to create the flow sheet. Then we have the various options available. The first one is mixer splitters, like mixers, splitters, and the split. Then we have the separators, flash column, decanters, like tank we have. Then we have the simple separation, vapor liquid separation. Then we have the heat exchangers, heaters, heat exchangers. Then we have the condensers. Then we have the columns. Here we have the distillation column and various other columns. There are slight difference here compared to the DWSIM. So this is DSTVU. DSTVU is the simple distillation. This is called shortcut distillation column. You can see we have also seen the shortcut distillation column in DWC. The naming is different, but this is exactly same as the shortcut distillation column. Here we have one more thing, and this is also shortcut distillation column, but rating. Rating means whether existing distillation column will be useful or not, whether required satisfying conditions are there or not, it will tell you. So both are shortcut distillation column, but one is for the new design and one is for the rating purpose. Then we have the rad frac. This is the rad frac. This rad frac is like it can deal with vapor liquid or gas liquid systems, or it can deal with not only lead distillation, it can also deal with the gas absorption, and it can also deal with the gas absorption and stripping. Sorry, distillation and absorption and stripping is possible in this one. This is the actual where we have seen, where I have showed you in DWSIM to get a temperature profiles and the concentrations across the plates. All the details you can get using the rad frac. And this for the liquid extraction. Then we have the multi for complex distillations. This is called multi-fracs for the complex distillation units. And we have the petrofrac, which is especially for the petroleum distillation, crude oil distillation. So these are the different columns. There are the these are the columns available, which is similar to the DWSIM. Then we have the reactors, right? Stoichiometric reactor. This is the simple conversion reaction. What we have shown in the DWSIM is the R stoic. R stoic is the exactly same as conversion reaction. Then we have the kinetic reaction, that's called the RE. This is the kinetic reactor. Then we have the equilibrium reactor. Then we have the Gibbs reactor. Then we have the CSTR and plug flow reactor and the batch reactor. So these are all the, whatever we have seen, exactly all these things we have seen in the DWSIM. So since this is a different software, the way we handle this slightly changed, but it will take just a few minutes for you to understand. As soon as I start explaining, you will understand very easily. Then we have the pressure changes, pump, compressors, valves, pipe and pipeline. All these things we have seen in the DWSIM. Then we have the manipulators like analyzers, measurements, like we have seen the analog function, adjust function, those things are there. And then we have the solids and solid separators. In case of DWSIM, we don't have very much, very good facilities or very good very good simulations not available for solids, but Aspen has a little better facility. So these are all batch models, batch user models, but mainly up to this one, solid separator. So whatever you have seen in DWSIM, the same thing is there in this Aspen also. Nothing difference. So that's why I said whatever we have seen the basics in DWSIM, the same things, everything is available in Aspen, and the procedure fundamentals are exactly the same. The way you see, the way the symbols appearance is different, and the connections slightly differ, but rest is same. The rest is the same. So today I will show with examples on these reactors. Then tomorrow we will go with other like separators, other systems we will see in the Aspen. I hope you're able to follow. You got any questions so far? Okay. So these are the PC and corresponding key viewer, any desk and password for the computers to access from the Cape Lab. So I will share these details with you. So let us see what we have done. This is about distillation column. Yeah, so same conversion reactor, CSTR, PFR, and equilibrium reactor and Gibbs reactor. These are the main differences, and I just showed you all these things are there in the Aspen also. So let's solve the problem what we solved with DWSIM, even with this also. Okay. Yeah. So we will do this ammonia synthesis. So we will take nitrogen N2 plus 3H2 gives 2NH class 2NH3. So this is the reaction, and we wanted to find out the equilibrium conversion. We want to find out the equilibrium conversion at, let's say, 30 degrees centigrade. At 30 degrees centigrade and 10 bar per shot. Then we want to do the sensitivity analysis. We have done this. We have done this in our BWC. So we will do that similar thing in the Aspen also. Oh, before that, since I've already selected ethanol water, let me quickly generate the VLE data. I'll show you first generating the VLE data for ethanol and water system. We have done the first VLE data generation for ethanol and water system in our class in the DWSIM. So we will do with that. We will do with Aspen first. Then we'll go to reactor. Then we'll go to reactor, as it is already there. So I have already showed you in the properties that I have selected. I have selected the two components, ethanol and water. We have selected the two components, ethanol and water. So you want to do the analysis, binary analysis. So if you want to generate the VLE data for this system, we need to do the binary analysis, or tertiary analysis. In case of DWSIM, we need to select the utilities option. But here we can directly click the analysis. Now here there are many possible analysis. One is pure component analysis, that is PET diagram or VT diagram. Then we can do the binary analysis. Then we can do the PT envelope. Then we can generate the solubility. If we have three components, we can also generate the ternary diagram. So first of all, we want to do the VLE data for ethanol and water. So we'll click on binary analysis. So as soon as click on binary analysis, this window will open. As soon as click on the binary analysis, this window will open. Now it's very clear to see the component. One is ethanol, component two is water. The compositions, basis is mole fraction, and we want to vary the ethanol mole fraction, then equidistance, and starting point is 1. Starting point 1 is 0 mole fraction, end point is 1 mole fraction. Number of intervals we wanted to do at 5. That means every increment of 0.20 mole fraction we have set. Now this is the pressure, so we want to be generate at this pressure. So in the while generating Tx by dice, P is constant. P is constant. At different pressures, we will have different Tx by data. So we are giving the atmospheric pressure and click on run analysis. So once you click on run analysis, and it will generate that neat TXY diagram. Neat TXY diagram. In case of DWSIM, we select utilities, then we select the stream, then we select the binary phase envelope, then we do the generate the data. In case of Aspen, it's simple that you go to the analysis and click on binary analysis, then select the required parameters, then you will be able to generate this data. So this way, it's a simple way to generate the BLE data using this aspect. Again, whatever fundamentals, as I said, are perfect, as same as it is whatever we have done in the DWC. Okay. So in this way, we generate the TXY plot. So I can just save it. Oh, basically, I'm saving this in that shared computer. So this way we generated this one. Then we can come out from this and we can start the new one. So where I want to show you the react analysis. So I'll just close this. Then whenever if you want to open new simulation, click here and click new simulation. Then new setup window will open. And here I want to do the react analysis. That is equilibrium reaction. So want to do simple ammonia synthesis reaction and generate the thermodynamic data, that is maximum possible conversion or equilibrium conversion versus effect of that on the temperature and pressure. So we select M2. You can type it as nitrogen or you can type it as M2. Both works. H2. Then in history. You can just press enter or press tab, then it will go to the new component. If you either press tab or press enter, it will open the new component head. So we have selected three components. So as soon as we select the three components, instead of checking what to do next, so something is like, in DWSIM, whenever there is a blue color, that means it's work. Similarly, here in Aspen, if the blue tick comes, that means we have given the required parameters for that section. So component specifications are okay, acceptable, because this is a blue tick. Now if you go to next, then you can see red color. If you see red color circle, if you see half-filled circle with red color, then that means we haven't specified the required things. So red color, this one means we haven't specified the required things. That is exactly same conventions are used in the DWC. If the whatever stream you have selected, if that is in red color, that means there are something we missed in the definition part. Now once it turned to blue color, that means whatever is needed we have defined. So here we have again we have to select the property package. So I will select SRK. I will select the SRK. Then as soon as I select the property package, that means it turned to blue color. That means I have given the required things. I have defined things properly. I have defined things properly. So just 1 second. Sorry, I had taken import tag. It is an urgent call, so I have taken it. So once we done that, we click OK. Then it will check whether all the thing is there or not. So sometimes we get a warning. Sometimes we get a warning. Now what the warning is here? Warning says the free water method should be when the main property method is SRK. So it is fine for the water conditions, but because here we don't have any component, so that works. If any water is there, then we have to select the steam TA also, steam along with the SRK. So that's fine. So we'll move on to the next one. Then go to simulation. We'll go to simulation. So first we define properties, then we go to simulation. In properties, we need to define two things. One is components, another one is property package. So here we want to do reaction. So we want to do the equilibrium reaction. We drag this equilibrium reactor. We drag this equilibrium reactor. Now in DWSim, as soon as click on this one, there's a pop-up window will open. Similar things actually we'll see here. All the details about this will be open. As soon as click on this one, all the details of this will be open. What are the flow sheet, what are the blocks, what are all missing, everything will be given. Whatever is in red color, that's we need to basically complete it. Whatever is in red color, that's we need to complete in the red color. So first of all, we need to give the streams. What is feed stream, what are the product stream we have to give. Now here, these are the material stream, exactly same we have seen in the DWSim. We have material stream, this is energy stream, and this is the work stream. So material stream, if you click on material stream, then you will see red color arrows. So these are the three things we need to define must. These are the three things we need to connect it must. So one is feed, another one is product, another one is product. This is vapor product and this is the liquid product. So click on that red color button, then drag it and click on that. Do a left click on red color arrow, then do another left click, then a stream will be generated, and that is the stream. Similarly, click on this red color, and here we get this one. That is one product. Stick on the red color, and click on the red color, and do this one. So we got the three streams. We got the three streams. So right click. If you do until you right click, the new stream should be continuously creates. So we can type, double click on it, and feed. And this is, if you double click on it, editable window will open, and this is the vapor product. Just say vapor. Wait. So we have one feed and two products. So in DWSim it is easier. We can say the streams. If stream is not there, just click it. There will be a little bit easier, made it more handy. So once you define stream, we need to define the properties. When you double click on it, outside that rectangular box, then you will see properties we need to define. It's in red color, that means we have it defined properly. So what do we need to define? What is the temperature? So we wanted to do the temperature 30 degree and 10 bar pressure. 30 degree centigrade and 10 bar pressure. So here 30. You can change units if you want it. You can change units if you want it. So whatever units you have, you can comfortably select it. Then pressure, 10 bar pressure. 10 bar pressure. Now, what is mole fraction? So we know that mole fraction. So mole fraction, mass flow, mole flow, volumetric flow, and mass fraction, mole fraction. So I'll take mole fraction. 1:3 ratio. So nitrogen is 25%, hydrogen is 75%, and in the feed ammonia is 0. Ammonia is 0. Now, how many mole flow rate? We can give any number, so 100 mole flow rate. So we have given the mole flow rate. So I've given the mole flow rate, I've defined the mole fractions. As soon as I define this, then it became mixed. It's become the blue tick. That means I have defined the streams properly. We defined the streams properly. Now go to next. Now we have to define the conditions for the reactor. You have to define the conditions for reactor. You can see R equal. R equal means reactor equilibrium. R equal here refers to reactor equilibrium. And this is the block B1. This is the block B1. You can see this is the block B1. You can change the name here. You can change the name here. That is equilibrium reactor. So I'll just do that, and you can see EQRE, equilibrium reactor. The specifications we need to define again temperature and pressure. So whatever is there in the red, we need to must We have defined them compulsory. So temperature 30 degrees centigrade and 10 bar pressure. Then I have given the temperature and pressure, then give the reactions. So there is no reactions already defined. So we click on the new. Come on. So, oh, so there's a power cut. Sorry, and in the Cape lab, I think computer was shut down. Sorry, please wait for some time. I'll just call the lab in charge and let him connect it. Come on. Students, I call that Malik who looks after the Cape lab. I don't know even why this UPS is not working there. I don't know. So we'll have to wait until it gets connected. So meanwhile, whatever I was trying to say is that, so once we define the streams, then we define the reaction, then we are you able to hear me?
Yes, sir.
So once we define the reaction, then we just simply, in case of DWSIM, we also run the simulation using F5, and here also we can run the simulation. So once you run the simulation, then we can see the equilibrium conversion values. Then we can do the sensitivity analysis. Then we can run the sensitivity analysis. So I hope I will get it. I will try once again. No, sorry. I think until it gets connected, I will not be able to show you in the Aspen. But okay, I will, as soon as the power comes, steps from there, I will do it and record it and post it in the Teams. The sensitivity analysis part I will explain tomorrow's lecture. So in tomorrow's lecture, I will try to cover some more Aspen one. But from this, probably you can understand or get an idea that most of the things are similar. Most of the things in DWSIM and Aspen are similar. All the concepts, not even concepts, even the handling, how do we handle software also is similar. So we'll stop here and we have 10 minutes. If you have any questions, I'm happy to answer. Otherwise, we'll stop the class here and we'll continue tomorrow morning. Okay. Are you able to follow whatever I explained?
Yes, sir.
Yes.
Okay. Okay. So thank you. No questions. You all may leave, and Adrija has some questions, so she will stay back, and others can leave.
Thank you, sir.
Yeah. Thank you all. Avai Sakhtar.